So the oxidation state of an atom is how many electrons it has lost or gained. So if it has lost electrons, it has a positive oxidation state. And if the atom has gained electrons, it has a negative oxidation state. So when octopus's blood becomes oxygenated, the copper atoms in hemocyanin lose an additional electron when they bond to oxygen. So this changes the copper's oxidation state from +1 to +2. So compounds containing the same transitional metals in the same certain oxidation states usually have the same or similar colours. For example, copper compounds where copper has a +2 oxidation state are normally blue. So octopus blood is blue when oxygenated because the copper atoms in oxyhemocyanin, so oxygenated hemocyanin, have a +2 oxidation state. So the vanadium in the protein hemovanadin, which is found in sea squirts, is almost always at a +3 oxidation state, which is why it's green, as vanadium is usually green when it's in a +3 oxidation state. So iron in humans' blood, when oxygenated, has a +3 oxidation state. So iron compounds in this oxidation state, like some rust, are usually anywhere from amber to red in colour. So oxygen transporting proteins in animals' blood are iron or copper based. So hemovanadin doesn't actually reversibly bind with oxygen and so doesn't transport oxygen. So there are other oxygen transporting proteins apart from hemoglobin or hemocyanin. So this includes hemerythrin and chloroquine. So hemerythrin is purple when oxygenated and colourless when deoxygenated. So hemerythrin is found in brachiopods. So these are animals of the phylum Brachiopoda. So brachiopods look like bivalves, except some are attached to the seafloor by fleshy stalks. And hemerythrin is also found in some phyla of marine worms, called sipunculids and priapulids. So chloroquine is green both when oxygenated and deoxygenated, and it's present in many annelids, so members of the phylum Annelida, which includes earthworms, leeches, and polychaete worms. So hemerythrin and chloroquine are both iron-based. So despite oxygen transporting proteins in animals on Earth being pretty much limited to just copper and iron, a cobalt-based protein called coboglobin, which reversibly bonds to oxygen, has been synthesized in the lab. So different sources contradict each other about its colour. However, some sites state it's amber when oxygenated and clear when deoxygenated, and some the other way around. So animal-like life on other planets or in alternative realities may have blood that contains proteins that contain transitional metals which are not found in animals' blood on Earth. So I drew the following drawings of hypothetical blood proteins because I thought they would look nice and not because I thought they would be good candidates. For example, chromium in a +6 oxidation state when bonded to other atoms, called hexavalent chromium, is very toxic to humans and other animals. So I've based the colours on the metal's oxidation state's typical colour. So pinoglobin is a brown manganese-based protein which is found in the blood of clams of the genus Pinna. So some sites state pinoglobin transports oxygen and that it is similar to hemocyanin, but I've read the abstract of a paper claiming it doesn't. So there might actually be obscure oxygen transporting proteins that occur in nature that aren't just iron or copper based.